Okay, now we have 7 types of mathematical function. Number 1, we have constant. Number 2, linear. Number 3, quadratic. Number 4, cubic. Okay, number 5, rational. Number 6, piecewise. And the last one is composite. Okay, number 1, constant function. The general formula for the constant function is y equal to fx or a0. Okay, what is a0? A0 means that any real numbers. Okay, this is symbol for real numbers. Okay, this one means real numbers. It can be negative number, it can be 0 or positive numbers. Alright. So now I have one example, y equal to fx equal to 2. Okay, basically, okay, if you confuse y and fx, you can also write y equal to 2. Okay, for this function, or you can write as fx equal to 2. So now the graph for this function, constant function, will be like this. Okay, since y equal to 2, so we know that there will be, okay, this is what we call it constant graph. Okay. Okay, constant function means that the graph will have the graph has two arrows. Okay, the first one to the right side and to the left side. So we know that since we have arrow, so the graph has no limit. Since the graph has no limit for the domain, okay, we read the graph from left to right. To the left means that the graph has arrow. So the graph will approaching to negative infinity, and let's say we have now, okay, arrow to the right side, also no limit, so means that there will be positive infinity. Okay, let's say you don't like this pattern, you can also write, okay, all R, meaning that in this graph, okay, the domain will be all R, means that all value on the number line. Okay, and then how about the range? Okay, range for this graph is, okay, range, we normally read the graph from bottom to up, right? So we now have the line is constant, the line is on y equal to 2, means that now we have our range is y equal to 2. Okay, why? Because of, okay, let's say you have graph like this. Okay, the graph, we have arrow for the side, for this side, and also this side. So we know that the graph both will go to the negative infinity. Okay, let's say the graph goes up. Okay, the graph goes up, like this. Okay, means that the graph will go to negative infinity and then to infinity. Okay, this is the pattern where we have graph negative infinity and positive infinity. But in our graph now, we have a constant graph where the graph stick on the line of 2. Okay, y equal to 2. That's why range is y equal to 2. Okay, number 2, we have linear functions, where the general formula for the linear function is y equal to fx equal to mx plus c. Okay, so now, okay, where m is the slope and c is the y-intercept. Okay, to sketch the graph for the linear function, now we have example 1, y equal to 2x plus 10. So the first thing you have to take note is, okay, the y-intercept. So the easiest way to sketch, you just okay, plot the y-intercept, and since we have here the positive slope, so the graph will go up. Okay, since my scale is not accurate, okay, not precise, so I will adjust this one. Okay, might be here. Okay, for the y-intercept. So now you can just sketch the straight line. So now we know that there's no limit for the linear function, therefore the domain, okay, so we know that the graph now pointing to the left side. So we now know that the domain will be negative infinity, and for the right side the graph same goes to the left side, no limit, so this is also infinity. Or you can also write as all all real numbers. And how about the range? Okay, for the range we know that, okay, for the left side now the graph show arrow, right? Okay, even though the graph goes to the always go to the left side, and then the graph will go to the bottom part, okay, to the bottom. So means that the graph will always show to the goes down, right? Goes down means that, okay, range will be negative infinity. And okay, now we have here the right side, okay, even though the graph will go to the right side all the time, and at the same time the graph also goes up all the time. So that's why we know that for the other one, okay, the graph will goes up. So now we know that this is again no limit, so both, okay, both domain and range give answer no limit or all are, right? So I hope you understand this part. And now we proceed the second example. I have example 2. Okay, y equal to x plus 5 divided by 2. So now, okay, change the pattern into like this, mx plus c. So we know that our c is 5/2 and x is 1/2. Alright, so this is positive slope. Slope is positive. So we know that the graph will goes up, and then this is the c, y-intercept. So to sketch this, we know that, okay, 5 divided by 2, the answer is 2.5. Okay, you can just estimate in the graph. Okay, no worries, because of we have no need to sketch accurate for this one. We just the important part you have to know the y-intercept and also the slope. Alright, so now we just estimate the value of 5/2 is here. Okay, and then the graph is positive, so the graph will show a positive graph. Okay, we know that the graph is like this, and same goes to the graph number 1. Therefore, our domain is all are. Okay, how about the range? The range also all are. Okay. Okay, number 3, we have quadratic function. The general form for the quadratic function is y equal to fx equal to ax square plus bx plus c. Okay, now we have, for information, we have 2 patterns of graph. Okay, pattern number 1. Okay, let's say we have positive number for the x square. Okay, the graph will be positive, okay, smiley graph. Okay, let's say we have negative graph for the x square. Okay, the graph will be call it as a frown graph, okay, sad graph. So now for the quadratic function, there are some steps for you to remember, okay, to find the domain and range. Domain and range, we have some steps. Okay, step number 1, you have to find the vertex. Find a vertex. Okay, what is vertex? Okay, for the vertex, the location is at here, the maximum point in graph. Okay, this one also the lowest point in graph. Okay, so for the vertex, the formula for vertex is y equal to negative b divided by 2a. Alright. Okay, sorry, not y, x. X equal to negative b divided by 2a. Okay, once you get the value of x here, to find the value for y, okay, you have to substitute the x value that we get in vertex into the equation, okay, to find the value of x. Okay, to find y, substitute x value into the function. Alright, and then for the second step, okay, find x intercept. So for the y-intercept, you have to set that y equal to 0. Okay, and then you will get the y-intercept. And then number 3, third, you have to sketch the graph. Okay, so we have 3 steps, okay, to find the domain and range for the quadratic equation. Okay, first, find vertex. Okay, second, find the x-intercept and set y equal to 0. And third, sketch the graph. Okay, not to forget the formula for the vertex. X equal to negative v divided by 2a. Okay, to find y, substitute x value into the function and then later you get the value of y. So means that vertex means the coordinate at the lowest point and or at the maximum point of the graph. Okay, so vertex must be in the form of coordinate. Okay, meaning that x coordinate y. Okay, this is what we call as vertex. Okay, now example 1 for the quadratic function. Okay, find the domain and range. For the, okay, this one you can refer your book page 43. Okay, question number 1. Y equal to fx equal to x square minus 2x. Okay, remember the first step. Okay, you have to find the vertex. Okay, to find the vertex, you have to remember the formula x equal to negative b divided by 2a. Where now in the function we know that okay, a equal to 1, b equal to negative 2, right? Okay, c, we don't have c, means that c equal to 0. So substitute the value into the vertex formula. So now we have negative b, negative, okay, negative 2 divided by, okay, a we have 2 multiplied by 1. Therefore, the value is 2 divided by 2. And we have the point of x equal to 1. Okay, to find y, substitute the value 1 into the function. Now we have 1 square minus 2 multiplied by 1. Okay, what I get this function? Okay, I get from here. Okay, so okay, for the y, we get here 1 minus 2. Okay, 1 minus 2. Therefore, y value is equal to negative 1. So now we have vertex. Coordinate is 1, negative 1. Okay, second step, you have to find the x-intercept. Okay, to find x-intercept, you have to set y equal to 0. Okay, now our function is y equal to x square minus 2x. Okay, so x square minus 2x equal to 0. Okay, factorize, so we take out x, so inside the bracket we have x minus 2 equal to 0. Okay, therefore to find the x-intercept, okay, the first one x equal to 0 and the other one x equal to 2. Okay, so this value okay, means this is the x-intercept. For the vertex, we have coordinate for vertex 1, negative 1. Now step number 3, you have to sketch the graph. Okay, to sketch the graph, okay, first we have the value for vertex. Okay, so for the vertex, we can just okay, estimate the scale for the graph. So now we have here 1, Okay, here is 0 in the origin and negative 1. And then we have here 1, and then for the y we have negative 1. So now this is the coordinate for the vertex. Okay, and we also have the x-intercept. We have 2, and then we have 0. Okay, for the x-intercept. Okay, to sketch the graph, remember the graph is now a positive graph since we have x square. Okay, so positive means that we will have the smiley pattern of graph. Okay, the graph will be look like this. Okay, from the vertex, and then now we have the x-intercept and like this. Okay, graph medium tak cantik Okay, now we can just find. Okay, sorry, I try once again. Better. Okay, so now we have graph pointing up for these two. Okay, pointing up and pointing up means that this is for the range. And now, okay, never mind, we start for the domain first. Okay, for the domain, we know that we read graph from left to right. Okay, so now our left graph, the graph will always goes to the left side. Okay, means that our graph will be negative infinity here. And how about the right side of graph? Okay, the right side means the graph will always go to the right side of the time, means that no limit for the arrow. So that's why for the domain there will be positive infinity. Okay, positive infinity. Ataupun nak tulis sebagai dia jadi all R. Okay, or all R. How about the range? Okay, the range will be different because of for the range normally we look for the bottom side of the graph, right? So for the bottom part, so now we have here this side. The lowest point is actually the vertex point. Okay, so that's why it is very important to find the vertex because of it shown the lowest point for the graph. So now range will start. Okay, we know the graph is the lowest. Okay, this is the lowest part. Okay, the lowest part is here. Okay, so we know that this is when y equal to negative 1. Alright, so when y equal to negative 1, and then we see the graph will goes up to the left and right side. Okay, will goes up means that the graph has no limit. So answer for the range will be y greater than or equal to negative 1. Okay, the lowest is negative 1. Maksudnya graph ini paling rendah. Okay, negative 1 dan ke atas. Okay, that one will be the range for this pattern of graph. Okay, this is the second example for the quadratic. So now we try to find the domain and range. Okay, first start vertex. So x equal to, okay, this one a will be 1, b negative 6, and c will be negative 9. So x equal to negative b, okay, negative 6 divided by 2a, 2 multiplied by 1. So we get here 6 divided by 2, and then x will be 3. Okay, to find y, you have to substitute 3 into the function. Okay, f3 means that 3 square minus 6 multiplied by 3 minus 9. So now we have 9 minus negative 8, negative 18 minus 9. So this one will be negative 18. Okay, therefore we know the vertex is 3, negative 18. Okay, this is very important because of this one, they give information about the range. Okay, later. Okay, second step, you have to find x-intercept. For x-intercept, you have to set y equal to 0. So x square minus 6x minus 9 equal to 0. You can just press your calculator. So we get the value of, okay, a1, b negative 6, c negative 9. So now we have okay, Okay, S1 is 7.24, and then the other one, x equal to negative 1.24. Okay, and number 3, you have to sketch the graph. Okay, to sketch the graph, we know now the vertex is at point 3, negative 18. So estimate 3 is here, negative 18 at the bottom side of the graph. Okay, just estimate the point is here. And then the graph is positive graph since we have no negative sign at the function. Okay, this is the vertex. And now we have the x-intercept is at negative 1.24, the other one 7. Okay, so now let's sketch the graph. So this is just estimate. Okay, the graph like this. Okay, nampaknya macam tak cantik, tapi I hope you understand. Okay, now we have the arrow sign for the left and right side. Okay, therefore the domain, okay, the graph will always go to the left side of the graph and also to the right side of the graph. Therefore we have the domain negative infinity to positive infinity ataupun all R. Okay, how about the range? Okay, range there will be, okay, this is the lowest limit. Okay, where the lowest limit shown y equal to negative 8, right? Negative 8 and above. So we can just write range y greater than negative 18. Sorry, negative 18. Okay, therefore this is the answer for the second example. Okay, okay. First, find vertex. Second, find the x-intercept. Set y equal to 0. Third, you have to sketch. Okay, this is the answer, domain and range for these two. Okay, this is number 4 cubic function. The general form for the cubic is y equal to fx equal to ax cubed plus bx squared plus cx plus d. Okay, so now same goes to the quadratic. Okay, we have two patterns of graph for the cubic. Okay, cubic function. Okay, let's say we have positive. Okay, positive, this one, x cubed. The graph will be like this. Okay, from right to the left side. Okay, this is x, this is y. Let's say we have negative x cubed. So the graph will be like this. Okay, from the left to the right side of the graph. Okay, so this is the pattern for the cubic function. Okay, to understand this, okay, we have example 1. Okay, in your book page 43, you see we now have y equal to fx equal to negative 3x cubed plus 3 plus 2. Okay, so we just estimate the pattern. Okay, okay, now we sketch the graph. Okay, you can also use your handphone, your Google. Just type www.desmos.com. okay, to sketch your graph. Okay, to see the pattern of the graph. So now I try this website where the pattern of my graph is like this. Okay, the pattern of my graph, since we have now negative sign. Okay, the graph from, okay, the graph is like this. Okay, since we have 2 here, and then okay, this is x, this is y. Okay, to find the domain, okay, we read the graph from left. Sorry. Okay, from left here. and right. Okay, we know the graph will pointing left all the time. Okay, the graph is not look like this, by the way. The graph is not pointing up all the time. The graph will like this, pointing up and to the left. Okay, to the left side all the time. So now we have here domain negative infinity, and then okay, for the right side we see that the graph is pointing to the bottom side, right? But if you can see here, the graph is also okay pointing to the bottom and to the right side of the graph. Okay, therefore our domain will be negative infinity to infinity, and for the range, okay, this one is much easier compared to the domain. We see that the graph pointing to the bottom and to the up, okay, to the, so that okay, therefore our range now is okay negative infinity. Okay, same goes to the domain, and pointing up, okay, and this one will be the infinity. Alright, mean that both is all okay, both for the domain and range. The domain range is all real numbers. Okay, for your information, for the cubic function, okay, for the domain and range, okay, this one all the time both is all real numbers. Okay, you can observe from the graph that I give you just now. Okay, we know that the graph just like this, okay, pointing up and pointing down, and then it always goes to the right side of the graph and then goes to the left side of the graph. That's why for the domain there will be all R. Same goes to the range. Okay, the graph will always pointing up and always pointing to the pointing down. All right, so therefore for the domain and range for the cubic, okay, always okay all R. This is very easy. Okay, very simple. If we compare okay from the rest function that we had discussed just now. Okay. Okay, for number 5, we have rational function, where the general form for the rational function is y or equal to fx equal to gx, okay, divided by hx. Okay, we can see that now we have two functions for the okay numerator gx. We have function gx for the numerator and hx for the denominator. Okay, the condition for the rational, okay, you have to know that okay denominator cannot be 0. Okay, so we have to find the numbers, okay, that when we put into the hx function we get 0. Okay, we cannot take that number as our domain. Now we have example. Okay, find the domain and range for the function fx equal to y equal to 5 over 9 minus x. Okay, so we know now that domain cannot be 0 for the rational function. So you have to check that, okay, for the denominator we have 9 minus x, right? So you have to find, okay, 9 minus x cannot be 0, negative x cannot be negative 9, x, therefore x cannot be 9. Okay, y cannot be 9 because of when we put 9 into this denominator, right? So the value will be 0. 9 minus 9 equal to 0. Okay, why we cannot put 0 for the denominator? Because of when you press calculator, let's say now we put 0, okay. Okay, 5 over 0, when you press your calculator, you get the value of error. Okay, so okay, this one, therefore we get our domain. Okay, therefore our domain will be all real numbers except x equal to 9, because of when we put 9 into the function we get error. Okay, right? So just to sketch the graph for this, I just want to show to you. Okay, now we have x 9. Okay, meaning that at the point of 9 here, okay, we have asymptote. Means that let's say our graph is just like this. Okay, this is just some example. Okay, might be our graph just like this, where we have here, okay, or we have this graph. Okay, maybe we have, okay, two functions. Okay, this is, we have straight line, and the other one we have quadratic, where we know that the graph is not continuous at x equal to 9. Okay, so therefore, okay, our graph now here all are except x equal to 9, because of we have asymptote. Alright, now what is the range, okay, for this graph? So for range, you have to calculate. Okay, for range, you have to make x as a subject. Alright, so now we have y equal to 5 divided by 9 minus x. Okay, so x, we want x as a subject, so multiply, okay, cross multiply. So we get here 9y minus xy equal to 5. Negative xy equal to 5 minus y. Right, so we bring 9y to the right side, become negative. And then x equal to 5 minus y divided by negative y. Okay, now y as a subject, okay, x as a subject. To find range, we have to make sure that for the denominator, this one cannot be 0, right? So the step is also the same. So meaning that now when we have negative y, okay, negative y cannot be 0. So y, therefore y cannot be 0. So for range here, okay, all are except, okay, y equal to 0. Okay, because of now we get y cannot be 0 for the denominator. Okay, that's all for the rational function. Okay, function number 6, piecewise function. Okay, before we find the domain and range for this function, you have to know the definition for the piecewise. Okay, for the definition, different, okay, what is piecewise? Different function for different parts of the domain. Okay, meaning that here we have might be 2 or more intervals. Okay, now we have interval 1. Okay, the function will be gx. And for the interval 2, okay, function for interval 2 is hx. Okay, so meaning that in this function we have 2 or more, okay, functions that we discussed just now. Right, now example 1, find the domain and range. Okay, now we have fx equal to 2x. Okay, interval we have negative 1. Okay, in between x is in between negative 1 and 3. Okay, so we know that this is linear function, right? Linear function. And then for the second one, we have, okay, x square. Okay, the interval is between 3 and 8. Okay, this is quadratic. Okay, to find the domain and range, you have to sketch the graph. Where, okay, you have to sketch the graph one by one. Okay, plot graph. Graph number 1. Okay, function number 1 is y equal to 2x. Okay, to sketch the graph, you have to draw a table. This is x, this is y. Okay, now we already have point x. Okay, remember now we have negative 1 and 3. Okay, put into the table. So negative 1 and 3. Okay, don't worry about the sign. Okay, you just now we just take the number and then find for the y. Okay, y means 2 multiply negative 1, we get here negative 2. And 2 multiply 3, we have here 6. Okay, this is number 1. Number 2, when y equal to x square. Okay, the step is the same. Okay, put the number. Okay, this one we have 3 and 8. Okay, put into, okay, don't worry about the sign, even though now we have the less than sign, but not we don't have equal, right? But don't worry, this one we use when we sketch the graph later. Okay, so okay, when x is 3 and 8, okay, what is the value of y? Just substitute into the function. We get here 9, we get 64. Okay, so now to sketch the graph, okay, now we back to graph number 1. Okay, the coordinate for number 1 is -1, -2, and 3. We have 6. Okay, graph number 2, we have 3, 9, 8, and 64. Okay, now we have coordinate -1, -2. So -1 is here, and -2. Okay, this is point. And then 3, 6. Okay, we just estimate point 3 here and 6 here. Okay, this one will be a straight line. Okay, straight line graph or linear graph. So we just connect these two. Okay, and then we continue second graph, y equal to x square. Okay, the coordinate is 3, 9. We have already 3, and then 9, we have here 9. And then the other one, 8, 64. We just estimate 64 is here, and then this is the, oops, sorry. Okay, this is 64. Okay, so coordinate for this, okay, this is quadratic. Remember, y equal to x square, so this is quadratic. So graph quadratic will be curved graph. Okay, like this. So now this is part where we apply the sign for the graph. Okay, now we have sign. Okay, less than. Okay, for this one we have less than. Okay, less than and equal for -1. So this will be close. Okay, close circle. Okay, for this one number 3, we also have equal sign. This one meaning that we have close circle. This one for the quadratic quadratic function, we have less than, but we don't have equal sign, means that we have here open circle. And 8, we have less than and less than and equal sign, so we have here close circle. So from here we have to find the domain. Okay, domain you have to read from left to right graph. Okay, from left we can see that this is close, so we have to use square bracket. And then the point is -1 up to 3. Okay, we have here close. Okay, and then the graph continue, we use quadratic graph. Okay, even though we have now one open, one close. Okay, so we consider this is close. And graph continue. Okay, the graph continue until point number 8. Okay, 8 we have square bracket because of this is a square graph. Alright, so other than this, you can also use this way. Less than x less than 8. Okay, this is the domain. Okay, for range, we read graph from bottom to from bottom to up. Okay, and then now we have from bottom, the graph start from -2, and then for -2. Okay, for range, this one, this is the bottom part of the graph. Okay, until here. Okay, so you have to write the range start from -2, and then this is close, so -2 up to here 6, and then the graph. Okay, 6 is a square bracket, and then union. Continue with this one. Okay, with this one we have open, so means open bracket, and then the point is 9. until here we have 64. We have a square bracket. Okay, so this is the answer for the domain and range. Okay, why we have union? Okay, this is union sign. Why we have to write separately? Because of now we have, if you can see for range, okay, we have a gap, okay, between the first graph and the second graph, okay, which we cannot, okay, to combine this we use union. Okay, the graph is not continuous and different from the domain just now. Okay, why? Because of now we read, okay, for the domain we read for the x, okay, x inputs, right? So even though we can see the graph separately, but the line, okay, we have here the point 3, okay, this is open graph. The other one is no, this is the closed circle, and then this is open, where this point already, we know that the graph is already continuous because of the point exists. Okay, meaning that 3 we can just continue from here -1 to 8 because of one close, okay, the circle one close, the other one open. Okay, let's say, okay, let's say this graph is open both, right? So means that this graph is we have a gap, okay, we have a gap between these two, so meaning that you have to use bracket. Okay, let's say I give you the domain for this example. Okay, the domain will be -1 to 3, and then we have open, okay, and then union 3 to 8. Okay, because of we have both open circle, meaning that this point number 3 is not included in the domain. Okay, so I hope you understand.